Welcome to this first lecture on automata and behavioral equivalences. In this lecture, we will show you how you can use automata to model the behavior of systems. We have seen this picture of the IBM 360 computer, and at the moment that this computer was designed, people were asking themselves, how can we model the behavior of such an IBM 360? And one of the persons who had very particular ideas about this was Robin Milner. Robin Milner in 1973 said, we are all looking at the behavior of these systems as functions. Functions from input to output. A program takes input and writes output, but that is not the correct way of looking at systems. What Milner said was, systems are always interacting with each other, and input comes, output comes, it comes all together, so a completely different model is required. What he said was that a good model is just this box, this blue box with buttons on it, and these buttons are actions or that you can imagine that you can press. And they stand for something that happens. For instance, if we take a computer, then it could be that we type an A on a keyboard, and that is an action that can happen. And it could be that an interrupt comes. Or with all these old computers, in the meantime, it could actually read a punch card. Old computers could still say beep as an output, and they could write messages on a screen. Well, these are all actions that can happen, and they can are input actions and output actions, and they really can happen in any arbitrary sequence. Now, the question is, if you have this behavior, how can we mathematically model it? Now, the first idea is that we take all these actions and we consider them as being atomic. So actions are events that really happen in an instant of time. So it's not that we type an A and start typing an A and then after a while stop typing an A. No, we see it as an atomic event. And that is what we will do. Within the whole community, there has been a long discussion on whether this is the good view or whether we should actually let events take time. But the conclusion was that if you want to use them to model software, taking atomic events is really the best choice. So, if we take these atomic events, what is then an automaton? Well, let's make one for a simple light bulb. So a simple light can be switched on and switched off, and there are two actions, namely switch on and switch off. We model that with these two things that are called states, and the whole light can be in a state off and can be in a state on. And this is a labeled transition system, or a state machine, or an automaton. And what can happen is that if you are in the state off and you press the switch on, these are states, and that is the initial state. So the initial state is the state where the system starts, and initially the light is off. And then you can have transitions that indicate that when an event happens, you go from one state to another state. So if you are in the off state, you do a switch on action, you move to the on state, and if you are in the on state and you do a switch off action, you go to the off state. So these are the actions, and we have the transitions. And such a system is called a labeled transition system or an automaton, but you will find quite a lot of other names in the literature. Okay, if you have such a system, then you can see that the system initially starts in initial state, so at the state at the top. And then you can do actions like switch on and switch off, and then again switch on and switch off. And what you see here is a trace of the system. So a trace is simply such a sequence of actions. And that shows what you can do with such a system. Okay. Now that we have this notion of an automaton, let's ask a few simple questions. Consider this automaton, and now it represents a banking machine in which you can insert a card and remove a card. And after you insert the card, there are two options. You either get money or you get no money. And with or without money, you will remove the card, and then the machine can behave the same again. The question is this a trace of this machine? The second exercise is about the same machine. And now the question is this a trace of the machine? And the last question is again whether this is a trace of the machine. Okay? So what did we see? We saw the notion of a label transition system to model behavior. We saw the notion of a state. We saw the important notion of an atomic action. A transition that tells us how you can get, using an atomic action, from a state to another state. And we have the notion of an initial state and a trace. Thank you for watching this first lecture. In the next lecture we will speak about non-deterministic behavior.